In the constellation Ursa Major, 12 million light-years from Earth, a galaxy is in the midst of a violent crisis. It's called the Cigar Galaxy, or M82, and it's one of the most extreme objects in our cosmic neighborhood. While galaxies like our Milky Way form stars at a leisurely pace, about 1 or 2 new suns per year, M82 is in the grip of a furious starburst, churning out new stars at a rate 10 times higher. This explosive activity is literally blowing the galaxy apart, sending massive filaments of hydrogen gas streaming into space. And in 2014, it hosted the closest Type Ia supernova in decades, Supernova 2014J, a cosmic explosion that astronomers studied in unprecedented detail. This is the story of the Cigar Galaxy, a cosmic firestorm that's consuming itself from within. Why does the Cigar Galaxy hold such a special place in astronomy? 4 reasons. First, it's the closest example of a starburst galaxy, a galaxy undergoing an intense episode of star formation that consumes its gas at an unsustainable rate. Second, it's expelling this gas in a massive superwind that we can observe in exquisite detail, helping us understand how galaxies regulate their growth. Third, in 2014, it hosted Supernova 2014J, one of the most important Type Ia supernova ever studied. And fourth, as a prototype for starburst galaxies, M82 helps astronomers understand what happens when galaxies interact and trigger explosive star formation, a process that was common in the early universe. In this documentary, we'll explore every facet of the Cigar Galaxy, from its discovery in the 18th century to the latest Hubble and Chandra observations. From the furious star formation consuming its gas to the superwind blasting material into intergalactic space. This is the complete story of one of the most violent galaxies in our cosmic backyard.
The story begins on December 31st, 1774. German astronomer Johann Elert Bode was scanning the skies from Berlin when he discovered a faint, elongated nebula near the brighter spiral galaxy M81 in the constellation Ursa Major. He cataloged it as simply another nebulous patch, unaware of its true nature. This object would later become known as Messier 82, though Messier himself didn't discover it. He added it to his catalog based on Bode's observations. 7 years later, in 1781, Charles Messier was finalizing his famous catalog of nebulous objects to help comet hunters avoid confusion. He included both of Bode's discoveries, the brighter spiral as M81 and the fainter, elongated companion as M82. Little did he know that this faint smudge would one day become one of the most studied galaxies in the sky. For nearly 2 centuries, M82 remained a curiosity, just another faint nebula in Messier's catalog. But in the mid-20th century, as telescopes improved, its true nature began to emerge. Radio observations revealed intense hydrogen emission, hinting at energetic processes. In 1963, astronomers Linz and Sandage published a landmark study showing that M82 was expelling vast amounts of gas from its center, the first evidence of a galactic superwind. The Cigar Galaxy was finally revealing its explosive personality. Let's establish where we are. The Cigar Galaxy lies at a distance of approximately 12 million light-years from Earth. It's part of the M81 group, a collection of about 34 galaxies that includes its larger neighbor, the Grand Design Spiral M81. At this distance, M82 is one of the closest starburst galaxies to us, which is why we can study it in such exquisite detail. Its light left the galaxy when our ancestors were just beginning to develop agriculture, a relatively short time in cosmic terms. In terms of size, the Cigar Galaxy spans about 37,000 light-years in length when viewed edge-on, but its disk is only about 5,000 light-years thick. That's what gives it that distinctive cigar shape. We're seeing it nearly edge-on, so its disk appears elongated. By comparison, the Milky Way is about 100,000 light-years across, making M82 roughly 1/3 the size of our galaxy. Its mass is about 10 billion solar masses, an order of magnitude less than the Milky Way's. The Cigar Galaxy's classification is somewhat ambiguous. It's often listed as Type I0, meaning an irregular galaxy with peculiar features. However, some astronomers classify it as an S0 lenticular galaxy, a disk galaxy without prominent spiral arms that has been heavily disrupted by interactions. The truth is, M82 is so distorted by its encounter with M81 that it doesn't fit neatly into any standard classification. Its chaotic appearance is a direct result of its violent history. The cigar galaxy is moving away from us at about 203 kilometers per second, based on its redshift. But more importantly, it's moving relative to its companion M81. The two galaxies are separated by only about 150,000. About 100 million years ago, the cigar galaxy had a close encounter with its larger neighbor, the spiral galaxy M81. The gravitational interaction between the two galaxies sent shock waves through M82's disk, compressing clouds of gas and triggering a cascade of star formation. Unlike a full merger, this was a flyby event. The galaxies passed close enough to affect each other but didn't merge. The effects, however, have been dramatic and long-lasting. The starburst was likely triggered by interaction with neighboring galaxy M81 about 100 million years ago. The starburst activity isn't spread evenly across the galaxy. It's concentrated in the central 1,000 light-years. In this relatively small region, massive star clusters are forming at an incredible rate. The most massive of these clusters contain hundreds of thousands of stars, many of them hot, short-lived, and destined to end their lives in spectacular supernova explosions. This central region is so crowded with stars that the radiation pressure and stellar winds have carved out bubbles and cavities in the surrounding gas. The stars forming in M82 starburst are not like our Sun. They're mostly massive O-type and B-type stars. Stars 10 to 100 times more massive than the Sun, burning hot and fast. These stars have lifespans measured in millions rather than billions of years. They produce intense ultraviolet radiation, ionizing the surrounding gas and creating the bright nebulae we see in images. And when they die, they do so catastrophically, as supernovae. Starbursts can't last forever. The cigar galaxy has been in its current phase of intense star formation for about 100 million years, and it has enough gas left to continue for perhaps another 100 million years. After that, the gas will be depleted, either converted into stars or blown out of the galaxy by the superwind. The starburst will fade, and M82 will settle into a quieter existence, its glory days behind it. We're witnessing the galaxy at a special moment in its history,